Resistance learning task. Learning objective. Solve simple rational equations that result in linear equations or quadratic equations with leading coefficient of 1. Electricity results from the presence and flow of electric charges. Electrons with a negative charge are attracted to those with a positive charge. Electrons cannot travel through the air. They need a path to move from one charge to the other. This path is called a circuit. A simple circuit can be seen in the connections of the negative and positive ends of a battery. When a circuit is created, electrons begin moving from the one charge to the other. In the circuit, to the right, a bulb is added to the circuit. The electrons pass through the filament in the bulb, heating it and causing it to glow and give off light.
If a circuit is not set up carefully, too many electrons can move across at one time, causing the circuit to break. We can limit the number of electrons crossing over a circuit to protect it. Adding objects that use electricity, such as the bulb in the above circuit, is one way to limit the flow of electrons. This limiting of the flow of electrons is called resistance. It is often necessary to add objects called resistors to protect the circuit and the objects using electricity passing through the circuit. More than one resistors can be placed on a circuit. The placement of the resistors determines the total effect on the circuit. The resistors in the diagram below are placed in parallel. This refers to the fact there are no resistors directly between two resistors, not in the geometric definition of parallel. Parallel resistors allow multiple paths for the electricity to flow. Two examples of parallel resistors are shown below. The resistor and the next circuit below are not parallel. These resistors are placed in series because the electricity must travel through all three resistors as it travels through the circuit. Resistance is measured in the unit called ohms and must always be a positive number. The omega symbol is used to represent ohms. For n resistors in parallel, R1, R2, R3, etc., the total resistance R sub t across the circuit can be found using equation 1 over R sub t equals to 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3 plus, moving on, L plus 1 over R sub n. For n resistors in series, R1, R2, R3, etc., the total resistance RT across a circuit cannot be found using the equation R sub t equals to R sub 1 plus R sub 2 plus R sub 3 plus, moving on, R sub n. Thank you so much for listening.
What is the total resistance for a circuit with two parallel resistors? One with a resistance of 3 ohms and the other with a resistance of 7 ohms. Draw a diagram of these resistors in parallel. So at first we will have to draw a diagram of these resistors in parallel. So R sub 1 and R sub 2. R sub 1 is 3 ohms and R sub 2 is 7 ohms. Here we got a circuit with two parallel. The equation is 1 over RT equals 1 over R sub 1 plus 1 over R sub 2. 1 over RT equals 1 over 3 ohm plus 1 over 7 ohms. So now we have to calculate the total resistance. First of all, resistor 1 is 3 and resistor 2 is 7. Now we cannot add these fractions up until the denominators are the same. Well, first of all, what are 3 and 7 all go into? 1 over RT. They will all go into 21, but how? So 3 times 7 equals 21. So 7 is our numerator and 21 is our denominator for the first fraction. For the second fraction, we have a 7. What will 7 multiply by to get us a 21? 7 multiplies by 3 will give us a 21. So our numerator for this fraction is 3 and denominator is 21. Now we can simply add those fractions up, which will equals to 1 over RT equals 10 over 21. Now in this case, you will have to flip the denominator by the numerator for both sides. RT over 1 equals 21 over 10. And now you will get the total resistance of the circuit. R equals 2.1 ohms. This is our total resistance of the circuit.
A circuit has been built using two paths for the flow of the current. One of the paths has a single resistor and the other has two resistors in a series as shown in the diagram at the right. For the two resistors in series, the second has a resistance that is 3 times the resistance of the first one in the series. The single resistor has a resistance that is 6 ohms, more than the resistance of the first resistor in the series, and the total resistance of the circuit is 4 electric current. Write an equation to model the situation and solve this equation. What is the resistance of each of the resistors? Now, in order to solve this question, at first we need to write an equation. Writing an equation is so simple and easy. At first, we just need to write the simple or basic equation for the electric current resistance, which is 1 over R equals 1 over R1 plus 1 over R2 and so on. It depends on the total resistors that you have in a diagram. So the total resistance is already given in the question, which is 4 ohms. So this is the total. So it's going to be 1 over 4 equals, the R1 is the resistor in the first path. The first path we have just a single resistor, which is R plus 6. So it's going to be 1 over R plus 6 plus 1. R2 is the second path. In the second path, we have double resistor, which is R and 3R. We're just going to add them together, so it's going to be R plus 3R. We found our equation. Now that we found our equation, we need to solve this equation. So we found our equation, which is 1 over 4 equals 1 over R plus 6 plus R plus 1 over R plus 3R. As you can see here, that we need to add them. So we're going to add them. 1 over 4 equals 1 over R plus 6 plus 1 over 4R. In order to solve this equation, we need to have the same denominator. In order to have that, we're just going to simply multiply this by 4R and multiply this by R plus 6. So overall, it will give us a product of 4R plus R plus 6 over 4R times R plus 6. Here we're just going to add the common factors, which is 4R and R, and we're going to multiply this. So it's going to be 5R plus 6 over 4R squared plus 24R. So here we stopped at this equation, and this equation we're going to cross multiply. We cross multiply to simplify our expression and to get rid of the fraction and to make it easier to solve. So when we cross multiply, it's going to be 4 times 5R plus 6 equals to 4r squared plus 24r. We're going to simplify by multiplying, so it's going to be 20r plus 24 equals to 4r squared plus 24r. As we simplified our expression more, we stopped at a quadratic equation, which is 4r squared plus 4r minus 24 equals to 0. Every time you see an expression that has squared and it is equals to 0, that means that it is an quadratic equation. To solve this quadratic equation, we need to simplify it more. As you can see here that we have factors of 4, which we can divide this expression to 4 to simplify it more. As we divide, it will give us a value of r squared plus r minus 6 equals to 0. We divided 4 by 4, which gave us r squared, and the other 4 by 4, which gave us r, and 24 divided by 4, which is minus 6. One of the most important factors of quadratic equations are factorizing. We stopped at this equation that we need to factorize in order to find the value of r. When we factorize, we need to find a value that when you multiply it, it will give you negative 6, and when you add them together, they will give you the product of r. So when we factorize, it's going to give us a value of r minus 2 times r plus 3, which is equals to 0. As you can see here that when you multiply negative 2 and 3, it will give you a value of negative 6. And when you add those values together, they will give you a value of positive r. Now we need to find the value of r. We're just going to set each bracket equals to 0. And the other one, we're just going to do the same. Set it equals to 0, and it will give us a value of negative 3. But when finding the resistance of an electric current, it's always positive. So you're just going to choose the positive answer. So the answer is r equals to 2. Now let's move on to the second part of the question, which says, what is the resistance of each of the resistors? We found out that the R is equals to 2. So, in order to find the resistance of each resistor, we're just going to apply R. Instead of R here, we're going to apply it by 2. And here, we're going to do the same thing. So the first path, it has R plus 6 as a resistor. So it's going to be 2 plus 6, which is equals to 8. So the first resistor is equals to 8. Let's move on to the second path, which has double resistors. R equals to 2. And here 3 times R. So 3 R equals to 3 times 2, which is equals to 6. So the last resistor is equals to 6 resistance. And that's how you find the resistance of each of the resistors.